Welcome to Pavithra Laptop Care. Today's topic is voltage in a load. Hmm? Voltage in a load. Okay. In last video, I already explained what is voltage and what is the voltage theory. One more time, I'll explain you voltage theory, what it will be in a circuit. See, consider it is a circuit. Here resistor is a load, this one is output. From here this is a positive and this is negative, consider it's a 19.5 volts. From here to here we call potential difference is 1 V1, because continuity will be same till here to here. After this load the continuity will be differ, so that's why it's called as a V2 from here to here. Okay, there is no other components, so that's why till here to here continuity will be there, so that's why it's called it's a V2. V2 means any name, not exactly V2, any name. Okay, for example, two components, resistor, capacitor, then positive, negative, negative, positive. See, till here to here it's a V1, here to here it's a V2, and here to here it's a V3. Understood? Last time already explained you. Once again I am explaining you V3. See, this one is V1. What are the voltage? Here 19.5. From here to here it will be same. 19.5 will be there. And after this resistor, it's a depends on resistor value. It's a R1. Depends on resistor value. The value will be changed. Voltage value will be changed here. V2 from here to here, this capacitor. Okay, this is some V2 voltage. After this resistor, after this capacitor, so here to here the resistance value, voltage value will be changed, so that's called it's a V3. So total in the circuit, the total voltage is equal to, see, 19.5 volts is equal to V1 plus V2 plus V3. In this particular circuit I am talking about. Okay, one more example. Just a minute, I'll drop this. You easily understood, I think so, this one. Okay, now I will erase this. One more example I will take. See, if it is a 4 circuit, see, positive, negative, here resistor, capacitor and coil. Okay, here what will be the voltage? From here to here it's a V1, from here to here it's a V2, and here to here it's a V3, here to here is the V4. Understood how it will divide? If suppose it's a 19.5 volts, then the total value 19.5 volts is equal to what? V1 plus V2 plus V3 plus V4. Got my point? So from here to here 1. This is called voltage theory. It has one more theory. See, in a circuit, the last one, if it is connected to the ground, there will be a 0 volts. See, here from here to here 1 volts, here to here 1 volts, here to here 1 volts. From here to here it all will goes to ground. So always in a circuit, the last voltage, if it is connected to the ground, then that voltage is called 0 volts. That also one circuit theory. For example, in a simple circuit, if it is a resistor, it is connected to the ground, here it is a voltage V only, because here there is no other component, so we will consider it as a V1 or V total. From here to here the voltage will be 0. From here to here the voltage will be VT total, what is there, that one. See, the component circuit will be same. This is a positive and negative, right? See what I taken, this is a load, resistor. Finally it got connected to the negative. Negative is nothing but ground. Negative is nothing but ground. Okay, positive is always positive. So here, from here to here, it's a V1, it's a V2. V2 always will be 0 because this is connected to ground. That's why from here to here, just common thing is last component. From last component, what are the voltage is connected? If it is connected to the ground, that will be 0. Okay, voltage will be 0. The first point, the component, till the component, the voltage will be the same as first. Same as first. Understood? This too is very, very important. Please don't forget. So again and again I will tell you in each videos. Okay. Today's topic is only this much. In a circuit, the voltage theory will be differ with each component. Okay. See, the total voltage should be addition of the divided voltages V1 plus V2 plus V3 plus V4. This concept you have to keep it in your mind. And other concept, the last component which is connected to the ground, that voltage will be 0 because the continuity has gone to ground, means whatever the voltage will be there, that goes to the ground. Clear? Now now we understood what is the voltage theory, and how voltage will divide in a circuit as per the circuit, that I will explain now. Now I will erase all the things. You noted down, I think so. Okay. So now in simple manner, what are the things I will tell you, just keep it in your mind. Need not to worry about what is that, what exactly I have spoken. In slowly you can understand all the things. This first time, no, you are unable to understand because you are the first time hearing these things, these words. If you are already in this field, then it's okay. But who are there in the beginning, then need not to worry. Okay. Again and again I will explain the theory. See, voltage in a circuit. Voltage in a circuit. Okay. The topic is voltage in circuit. The circuit. I already told you this is the load. Okay, load is connected to the ground. One is positive point and second one is negative point. Consider this load is an IC, integrated circuit. See, one is completed, right? This is called VCC or V in. Okay, one positive should be there and negative should be there. Once the loop is closed, then it's called a closed circuit. Right, this is called closed circuit. Now this, if you consider it as IC, it will give the appropriate result, output. Okay, this concept you have to understand. If this one is a load is a IC, then IC, according to the load, the IC will give the appropriate output. Okay, for example, I will tell you, if IC number 1, if IC is a step down IC, step down, then what it will do, it accept 19.5 volts in a loop and then it will convert to 3.3 volts. Okay, and it will convert to 3 volts LDO. This is called step down IC, which downs the voltage. It reduces 19.5 volts and it downs the voltage and gives these two appropriate output. Okay, one more step down IC, which reduces 19.5 volts and step down to 5 volts 5 volts LDO. Just assume one circuit, if this load is a IC, then what it does, so it accepts positive and negative load, completes, then it gives appropriate output 3.3, 3 volts LDO, 5 volts, 5 volts LDO. Like that, similarly, if load is an IC, it may give 1 volts or 1.5 volts or 1.05 volts or 1.8 volts or 2.5 volts or 3.3 volts, 5 volts, and so on. Maximum 24 volts, like that. Understood? So just once again I will tell you, if this one we consider it as a load, okay, the circuit, the closed circuit, for closed circuit we have to give the positive and negative terminal, then only we called it as a closed circuit. Okay, if we consider it as a IC, it is a IC, then the IC load will give some outputs. What are those? 3.3 volts, 1.5 volts, 1.05 volts, 1.8 volts, 2.5 volts, 3.3, 5 to 24 volts, anything. These are IC characteristics. Okay, this one in considering it as a voltage rated load. Okay, these all are called voltage related load. See, voltage related IC, nothing but load. Okay, now new chapter, one new thing I'll teach you. This one you noted down, you understood, I think so. Once again I'll explain this again, not now. Now one more thing I'll tell you. Now you understood, in the load, if I give a load, if we consider this load is a IC, in the laptop circuits, this particular load will give output. What output? Voltage output. But in some ICs, the output will be signals. Okay, the difference between voltage and signal is this also a kind of voltage, but controlled voltage, by an IC. This is the major difference. Okay, the signal is controlled by an IC, that is called signal. The controlled voltage is nothing but signals. Now you understood what is the voltage and signals. Okay, once again I will repeat, not now, again I will come back to this, just you remember that words. Okay, voltage and signal. Now I told again load. Okay, again I will write a load. Now this load will have positive and negative terminal. It will be complete circuit load. Consider it as a IC. Okay, that also IOIC. IOIC in the sense embedded controller, that we called embedded controller IC. That also one kind of IC. This will give the signals, accept or reject or produce. What it does, signals, it accepts or rejects, or it produces the signals. This IC work. Okay, if we consider IC as a load, first it may be voltage IC, or it may be signal IC. Understood? This point is very important. Okay, IC, if IC is a load, then it will be voltage or it may be signal. So what are the signal ICs and what are the voltage ICs? Now I'll clearly tell you in the laptop. I'll drop this one. Need not to worry if you are not understand also. I will explain again and again. Then you come to know. See, if we consider it as a load, the positive and negative terminal is connected to the load. If we think it is IC, the particular IC, what is that? Embedded controller, processor, and PCH. In the motherboard I am talking embedded controller, processor and PCH. These all are signal related ICs, signal producers, works through the signals, means it accepts, rejects and produces. Understood my point? If the load is an IC, the IC, if it is a EC or processor or PCH, these ICs will produce as the signals, like a traffic signal. In traffic signal, two lights will be there. One is red, yellow and green, right? It accepts positive and negative. It become a load and it gives the red signal when the particular timings, particular time delay, it gives the red, yellow and green. Not at a time. If it gives at a time, it will become as a only bulb. There is no difference between the controlled signals and voltages. This will work only through voltage. Voltage doesn't have any control. Okay, signal is a command, okay, which will command to give the red, then red light will glow. The command, if it gives the command to glow yellow, then yellow will come. If a command goes to the third one, green, then green will come. Understood my point? What are the voltages and what are the signals? Once again, I'll drop this and I'll explain from the beginning. Okay, in this class itself you can learn whole laptop how it will work. See, now you come to know load circuit. Okay, closed circuit, if it is a closed circuit, if a load is an IC, the multiple IC will be there. Some ICs will produce voltages and some ICs produce signals and voltages. Got my point? Okay, this is common thing in a laptop. If you know this concept, you can easily understand the circuits. See, circuits, many circuits, I am telling you circuits. Okay, circuits is nothing but load. The complete loop is nothing but circuits. This will be having multiple in laptop motherboard. To identify these loads, these circuits, we will be having a notes, that's called schematic. Schematics. Okay, I'll rub this, I'll write. Okay, to understand the circuits, see, laptop motherboard having multiple circuits. For identification, a notes will be there. A notes, the PDF notes will be there, that we called schematic. What it contains? It contains the circuits, the closed and open. Okay, all will be there in this particular PDF notes. That's called schematic. I will explain today what is the circuits and what it produces. It's a voltage or signals. One by one, complete schematic I will explain today now. Okay, need not to worry. It's today's overloaded, or you can't understand like that. But it's very important things. Day by day, continuously, I will help you out. Okay. This is called schematic. Now I'll rub this. One more in a schematic, one common point I'll tell you. In a schematic, the voltage I told. If consider V1 is here to in this circuit here, this is V2. Again, in some other pages in a circuit, if they given here V1, then this one having continuity with this, both are same. The name should be same except any other characters. If it is a V1 underscore 2, then it's not related to this. Exact name should be there, then we consider it as a same voltage. Continuity will be here and here, continuity will be the same. See, one more circuit I'll tell you. In this, if we call it as a V1, then it has connectivity with this. V1 is the same, V1 also same, and here also same. For example, it has 3 volts, here also we have 3 volts. If we check in multimeter, the continuity will be same. It gives beep here. That also you should remember. You should not forget. Okay, I'll rub and neatly I'll note down. See, I'll write neatly. Once again, I'll tell you, if a circuit, this also a circuit. If here is a point V in, if I tell, here I given is a V in, then this V in and this V in are same. The voltage V in will be same and it has continuity. Here suppose V in underscore 1, then it's not equal to this. Okay, this not equal to this. So both are different one. This name is different and this name also different. Continuity won't be there. If there also, it won't match. The exact one is V in is always V in. V in underscore 1 is always V in 1. See, if here V in 1 is given, then it has the continuity, same continuity it has. So both are same. Okay, these two are same. This not related to this. This point you have to understand. Okay, if you follow this rule, easily you can understand the schematic. Okay, got my point? Now I will open a schematic and I will explain how to identify a load and what it gives. Okay, directly I will open a schematic. See, here it's a, just you check this that note I told you. Then in the note, the LA-H501P, This is the motherboard model number. Okay, this is the motherboard model number. This one is motherboard schematic document. Motherboard schematic document. The Compel Confidential. Compel is a company. They made an confidential data of this particular motherboard. The revision is 1A. The first they release, right, every 6 months or 1 year. If any modification is there, they will release as a revision. Understood my point? Here it's a motherboard schematic document LAH501P. Here is the released date. Here is the submodels. Same motherboard. If any changes will be there, that particular changes motherboard they will make. See, in later you can understand what are these things. In this notes, just I will explain what are the load and what are the voltage and what are the signal. What are the difference between those things? That clearly I will explain one by one. See, now what I told, here is the circuit. This circuit is connected to the EDP. HDMI. Just you assume. If you can't understand also, no issues. Just I will explain. This one is RAM. This one, what is this? Coffee Lake H processor. Processor is connected to what? HDMI, EDP and RAM. And also is connected to the PCH. It's directly not connected to the SSD or HDD or somewhere in USB. The only thing is RAM, EDP, HDMI are connected to the processor and also PCH. This is PCH. This is processor. Okay. The PCH connected, this loop is connected to this one, this one, this one, this one and here. Generally I am explaining you, just you understand what I am going to tell. These are a circuit. See, the speaker is a circuit. Here headphone is a circuit. This point what they given is a block diagram. These all are called circuits. Each circuit will produce each voltage and each signals. Some circuit will produce some voltage come signals. See, this one as given in the page number 38. This one is in the 40. This one is 77. Am I clear? Okay, once again I will tell you this processor. Just I already explained you. Processor is a load. Processor is a load which is connected to these things. Okay, which will give signals or voltages, appropriated signals or voltages related to these particular connected devices. PCH, EDP, HDMI, RAM. Understood? Only this much you have to understand. This is the black diagram. I already told you ENE. This one is called embedded controller. IO, okay, which is connected to PCH and keyboard and touchpad. This circuit, this is one complete circuit, is connected to these devices. And here SPI ROM, it's a BIOS IC. This one is connected to PCH. This is a hard disk related. What is that? Page number 47. This is a load. A load is connected to this load. This load is connected to the PCH. And these all are interlinked. Interlinked in the sense each communication signal will pass through this SSD and Wi-Fi and LAN and PCH. Okay, understood my point? So these all are separate loads. So what I am going to tell you is, in the laptop these are the loads. These all are separate loads. I told you laptop contains multiple loads. Okay, each load produces voltage and signals, or only voltages or only signals. That we come to know the page number 38 for EDP load, page number 40 is for HDMI load. Okay, now in this schematic generally I will explain you what are the voltage load and what are the signals load. Okay, see, here is a black diagram. Here is a black diagram. Here DC jack, DC in, first voltage goes to the laptop is called DC in circuit. See, that circuit is connected to charger circuit. This circuit is connected to charger circuit. This charger is directly connected to these all are circuits till here. See, 19 VB charger output. Once we connect the positive and negative, this load gives the voltage of 19.19 V underscore V in or battery voltage 12.6 volts. This produces plus 19 VB. This charger IC, once again I am telling you, charger IC is a complete load. Complete load given 19 point, what is that, plus 19 VB volt, plus 19 VB volt. This volt again is connected to these all are loads. One load voltage, this load voltage, this is called actually voltage, is connected to this one PUZ 2, 3, 4, 5 is a one load which works through this enable. See, consider this is a load, this having 19 volts input and ground is the output. I mean positive and negative is a complete loop, complete circuit. This IC will work when this particular DRVON enable signal comes, then only this will give the output of this one VCC core. Okay, when it gives this enable signals will come, then it gives appropriate voltage signal or particular voltage. See, once again I will tell you, this one is complete loop. Charger IC is a complete loop. This loop has given plus 19 VB. This plus 19 VB has connected to multiple circuits. Just one example I have taken here. This particular load has given to other load. Other load in the sense here positive and ground will be there in that this particular load. Then load complete loop will complete. But this IC will give the appropriate output when this particular enable signal will comes. See, this particular enable signal comes, then this one will give this PL. PL is the coil outputs. PLZ 1, 2, 3, 4. Then CPU is the VCC core voltage we will get. This is the voltage plus VCC core is the voltage. This is the signal. Once signal comes to this circuit, then it will give the output of CPU VCC core. Second one is same. This charger IC produces plus 19 VB. That one has given the second load, that is works when DRV on signal comes. This is enabling signals. Enable signal in the sense once this signal will come, then only this circuit will complete and gives the appropriate result as plus VCC GT. Understood my point? 19 volts VB is given to this circuit. This circuit using this enable signal, it produces PLG1. PLG1 that is plus VCC GT. Got my point? Next, same charging IC has given the 19 volts output. Again it has given a circuit. Again it has taken enable signal. It has given PLA. The result is plus VCC SA. The result is plus VCC SA. And again the same charging IC has given to this circuit. The enable signal 3V underscore EN will come to this signal, then it gives appropriate output plus 3 VALP, that is PJ plus 3 VALW. That is a voltage name. This is voltage name that initially I told you. This circuit contains 19 volts and it gives, it receives the enable signal and it gives the appropriate output. It's a step down output through this PJ30L coil. Okay, and again this charging IC has given plus 19 VB enable. It receives this complete circuit. It gives two appropriate outputs. See, one is 1.2 volts, other one is 0.6 VSP. And again this output connected to this, what is that? This coil, and it produces plus 1.2 volts VCC PLL to the CPU. It goes to CPU. This particular voltage is given to CPU. This is memory voltage. Okay. Now again, this 19 volts plus 19 VB, the charging IC has given 19 VB. This is connected to this particular load. It receives this enable signal, then it has given these two, right? Like that. Here this PU1101 load is completed when 19 volts has given to this input as input, and then it has given a output when the signal comes. This signal comes to this load. Then what it has given? Plus 1.05 VALWP. That's through PJ1101 plus 1.05 VALW always. Again that voltage has given to multiple circuits, and that particular circuits completes through this using these circuits, and it has given to this particular RQ5, and final result is VCC ST. This voltage it has given final voltage to the CPU. This one is to the PCH and this one is to the CPU. Okay, and again this 19 voltage has given to this circuit, receives the enable signal, has given 1.0 VCC IOP voltage, and then through this one it has given, and the final output is plus VCC IO has gone to CPU. And here again the charger IC output plus 19 volts has given to this circuit through this enable. It has given this voltage through this PJ, and finally it has given this voltage, and again that particular voltage has given to multiple circuits, and then multiple circuits has given these voltages to the CPU, PCH. Here it's a codec, here GPU. I'll explain you in the future what are these. Just you have to come to know, you have to understand what it is. Okay. Again this charger IC has given PU501. What it has given? It's a plus 5 volts always P through this PGA coil, and finally it has given plus 5 VALW, and this one again it is connected to the multiple circuits. Each circuit has given this particular voltage, and again this voltage goes to particular component. See, particular circuit, it produces particular result. See, okay, and again this 19 volts has given here PUW1, and again this one it generates, here is enable, this one is the enable signal, and this is the GPU B plus it produced, and here finally 1.35 VSD GPU voltage produced, and here plus 19 VB. Okay, this again 19 volts has converted as a 19 VB CPU, and it has given to LX1 here invert power, and it has gone to power panel. See, this is the concept. It's a very simple concept, right? Just it is a load. The load has given positive and negative signals, voltages, and that voltages has gone to some other circuits. That particular IC which I told you, that IC, that circuit, the complete circuit will complete once input voltage will come, then it receives particular signals, and gives the appropriate voltages. Okay, today's class is that's it. If I explain you again, you will get confused. Just you have to understand only this much. Okay, in randomly I will show you what are the voltage and what are the circuits. You have to type charger. Charger is a first circuit in a laptop. See, this is a charging IC. See, 19 volts path as given here. This is the IC. See, here is the pin number. What it is? AC in, DC in. See, here is the DC in. This particular voltage plus 19 volts V in is coming through DC jack. See, this voltage is relevant to this DC jack voltage. This one is DC jack voltage. What I told, the name is same, plus 19 V underscore V in. If you check multimeter from here to here, if you put the probe from here to here, you will get beep. Beep in the sense continuity. Okay, that voltage has given through this diode and has given to the pin number 18. And here is the positive and negative should be there, right? See, what is that? Ground point. Here is the AG and ground. See, this one connected to the ground. Ground, GND. Okay, AGND. One circuit should be having one voltage and ground. Then it gives appropriate result. See, here its arrow mark has gone, and here it has given through this coil. The output is PLB1. PLB1. Okay, like this, many circuits are there. Many circuits are there. See, here it's a 19 volts. 19 volts VB is the input. This IC input. See, here is the V in. In it has taken, and one is ground. This is a complete circuit. Once it complete circuit, this IC is produced what? 3 volts VLP and coil output. Coil output plus 3 VALP. This IC completed the circuit using this V in and ground. Once input and ground has come, then it produces plus 3 VLP and 3 VALP. Like that, same concept for all. See, here it's the enable signal, enable 1 and enable 2. From other side it has taken and it produces the final output. Except these signals, enable signals, it won't produce these voltages. Keep it in your mind. Except these enable signals, it won't produce these voltages. Again, one more IC, 19 voltage in and ground also will be there. Ground here somewhere, see here. Once this loop will be completed, then it given plus 5 VLP and 5 VALWP. Right, these two voltage, this particular IC has given, IC number is this one, SY8270C. Like that, same IC, one more IC has given ground in and appropriate output. Again, one more IC, what is that? Ground. See, here is the pad ground, V in. 5 volts is the VDD, is the V in. Okay, here is the completed, this circuit has completed, then it has given appropriate output. See, 1.2 VP is the output voltage through PLM coil. Here it's this also is the output 0.6 volts it produces. Okay, here is the 2 voltage this IC will produce. Total 3 will be there. When this S5 and S3 signals, what I told, these signals, once it receives, then appropriate voltage will come, 1.2 and 0.6 volts. And again one more IC, this IC having input and ground, right? Loop will be completed, complete circuits, then given appropriate output plus 1.05 volts. And again same in ground output 1.8 VLP, and again in enable ground output this one. Same, this is the output. What is the input? In ground. This is the IC complete circuited. Circuit has completed. This through this coil. This is the voltage. Now you have to understand the concept of voltage and signals. Okay, the circuit, see, input it has taken, output it has given VCC core. When these are the enable comes to the particular circuits, circuit has given here. This is the continuation of this. See, this is VCC input, ground should be there. Any IC you can find out, ground should be there, then only it gives appropriate output. See, right? So today's class that's it. So just you have to glance what is voltage and what is signal. Once signal comes, some ICs will generate particular voltage. Some ICs without signal also it will produce the voltage. And second thing is V in concept. The name should be same. If name should be mentioned same, then particular voltage will be the same. Okay. We will meet in the next class. Thank you.